Okay. Oh God, you all quieted down at the right time. It was almost like you knew I was going to start. So, okay. So some announcements before we get started. There is looks like a Tupperware dish. Yes, looks like a canister. It's the ITU vase of contribution for the Japanese fund, if you feel so inclined. Totally optional, you don't have to do it, but if you're looking for a means of donating and you have some extra cash you want to donate, the funds, 100% of the funds go to the Japanese Relief Fund that's being sponsored by ITU. So it's part of the, what is it called, ITU Cares or something? Or I remember reading that. Oh, healing, meaning for healing? Dealing for healing. Dealing? Dealing for healing. It sounds like a Vegas game. All right, so that's announcement number one. Announcement number two is that there is hopefully circulating. Have you started circulating them yet? Okay, circulating sometime throughout the course. They're going to give you the student survey, so you get to rate me. And it's completely confidential. It's totally handled by the TAs. I don't see it. I don't read it. I don't get anything from it. So it does not affect your grade or anything of that nature as well, because I don't see it. And the TAs, aren't going to use it against you for anything either. So feel free to be honest on it. Give some feedback. What you like about the ITU classes, what you don't like about it, what you like about me, what you don't like about me, because it's good feedback that we can use in the future to make improvements, which is the purpose of it. So it's your opportunity to voice your concerns or place some compliments. You can also do that as well. Today we're talking about assignment number 4, and the assignment number 5, another announcement number 3. I think I have like 5 announcements today. Announcement number 3 is that assignment number 5 is optional. It's dealing with Java threads, and this is the week before the final exam review week, and I'm not going to push threads in the entire 1 week. So you don't have to do assignment number 5. If you do assignment number 5, it's worth 5 points extra credit towards your grade. So if you've done it already, you already got 105% if you ace everything else. But if you don't have the time, you don't have to do it. So today we're talking about the last assignment, which is assignment number 4, deals with swing components. I'm going to show you how to put it together, show you about the classes and the packages and everything that you should be concerned with. And which leads me to announcement number 4-ish, I think it's number 4 at this point, that next week is the final exam review. I'm not reviewing this week. I'm reviewing next week. So next week we will go over everything you need to know for the final exam. I will be recording it, so if you know people who aren't showing up, they can go online. They could listen to the recording. The recording will be at bhacker.com. It'll probably end up being in the ITU EMS as well. But it'll probably show up at bhacker.com a little faster, or on YouTube a little faster. I try to put them up immediately after the class. So you'll see, hopefully, everything you need to know for the final exam, which is going to be next week is the review, not the exam. Announcement number 5, there were 5 of them. I tried to remember them. Number 5 is that the final exam schedule has been posted already. And if you haven't been attending, and this is your first time here in a while, you can find the schedule at bhacker.com. If you don't like your placing on the schedule, final exams start in 2 weeks. For this particular class, it's on the 20th, is it? Yeah. What's the Monday? 20th? Yeah. Or is it the following week? The 21st? It's 25th. Yeah. We have 2 weeks of final exams because we have so many students. I need to space you out. Plus, we want to make sure that there's peace and quiet and room to write and stuff like that. So I've split you out into groups. And so if you don't like your grouping, just let me know. The groupings run for 2 weeks straight. So if you don't like the first week of the exams, you can take the second week. You can take it the last weekend, which is April 30th. May 2nd is the very last weekend to take the final exam. If you don't take the final exam, you'll end up with an incomplete in the course. So you want to take the final exam. All of the assignments and everything is due by May 9th as the very, 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 very last day. You should have already be turning in, this weekend is April, no, is it this weekend or next weekend? Next weekend is April 17th, 18th weekend? 17th? I probably should get a calendar. Anyway, that's when the midterm exam is due. So you want to make sure you could turn the midterm in because we want to start grading stuff so that we can get your grades out. We can't grade anything if you guys don't turn anything in. A lot of people wait until last week. And some of the exam dates are being posted, and some of the assignment due dates are being posted as the 20th, the 24th, the time, because we're trying to, now they're at the 9th. Well, I think the initiative was to try to get you to post things early, because what you don't want to do is wait until like maybe the 1st of May, that last week. The system's probably going to go down. I mean, I could probably predict it. The probability of it going down is very high because of the volume. So everybody will be posting assignments that week. And you'll have a problem getting in. You'll have to try several times, and it will be a hassle. So if you want to make sure you get everything in without any hassles, do it before the last week. Don't wait till the last day, the last week. Otherwise, you run into the situation where everybody else has waited as well. And plus, some of you are probably going to be leaving. You know, they go summertime, and not everybody stays for the summer. So the earlier you get in, the earlier you get out. I mean, so as soon as you get everything posted. You don't have to post everything before you take your final exam. If you want to take your final exam, I believe the earliest date you could take it is the 16th, which is next. It's on a Saturday, Sunday schedule for the weekend. It's not this particular class, but it's another time in which I'm doing an exam. So any one of the posted times that I'm hosting an exam, you can come in and take any exam. If you're taking multiple classes, you could take all of the exams in one sitting. It's a lot of work. But you could go back to back to back to back. And for those of you who are curious, the format is all multiple choice for everything. And there'll be many, many different versions of it. So don't come in with a list of multiple choice answers because they're going to be wrong eventually, or essentially. So it'll be about 25 questions, multiple choice. If you're trying to plan your time out, you'll be looking at around the same quantity, same format for all of the exams. So if you're trying to do 3 of them back to back, just imagine you'll be doing 75 questions, multiple choice, in 3 different subjects if you're taking 3 different classes back to back. So before we get started, any questions about any of those announcements? No? Well, it's finally spring in the air, and my allergies are acting up. My head's a little fuzzy, because, I'm just warning you ahead of time, because I'm on allergy medicine that knocks me out. But I have coffee, and I'm coming back to life. But if I stop and cough and stuff like that, I'm not contagious. It's that cottonwood. It's that little white flower that's in the air right now. I'm allergic to that. So every year I have the same problem. This year it's actually happening kind of fast all of a sudden because we've had the warm weather, then the cold weather. Now we have the wind going on. It's a nightmare. Anyway, but I'm here. We're going to get through the lecture. So, but yeah, if I sound sick, it's because I have allergies. All right, so Lecture 8 is about user interface with Swing. And what we're looking at in terms of an overview of what we're going to cover today is everything that's related to GUI. This is not applets, this is an application. Works with applets, works with applications, works with Java beans, works with everything. You can use Swing as a Java component with everything. In your 4th assignment, you'll be making a menu, a text editor. And so you'll have to work with the components to put it all together. So what we're looking at is class packages that are in Java x.swing. So at the beginning of the program, you're going to be importing this package. And the components that you're looking at are interacting with the mouse, the keyboard, and any other form of input. And it's displaying on your screen as output. The basic GUI components that we're going to look at today are the Jlabel, JTextField, JTextBox, checkbox, combo box, list, panel, all of the different components. And most of the Swing components are written completely in Java. There's a combination, though, of some external libraries that are used for interfaces. Some of it is actually written in assembly language. Not all of it is Java-based. So the main stuff is going to be particular towards the JVM, which is going to be written in Java. So we have greater portability, greater flexibility. All GUIs look the same, and it depends on the host JVM as to how the windows are going to appear. So no one's ever asked me this question. Well, actually, a long time ago, people used to ask this question: how do we get a Windows-looking program on a Mac, or a Mac-looking program on a Windows? You can't do that. Because you're calling libraries that are working with the underlying operating system. And those libraries are going to use the window frame motif, the style of the host operating system. So if you write an application, because we're working with cross-platform compatibility with Java, you write an application for the Mac, you can turn it around, just recompile it, or actually just, you don't even have to recompile it. When you run that on the multiple different operating systems, everything makes underlying calls to the operating system. The windows, the frames, the controls, everything is going to be presented towards the host operating system by theory. In the old days, we used to actually have to design this stuff. It's really easy, which is how I can cover Swing in one lecture, and you'll be armed and dangerous and ready to go. So the AWT Abstract Window Toolkit components are platform dependent. Some of the Swing components are still dependent, like JFrame is dependent on the platform. But everything else is actually platform independent. So most of the Swing components that are written in Java provide components that are compatible across the board. So here's some common superclasses of many of the Swing components. Obviously everything comes from object. So we have Java lang object as the top component in the hierarchy. We have component, container, and then Jcomponent that runs inside of that. You don't really have to know anything about the hierarchy, but it kind of puts everything into perspective when you start considering the classes in the structure. So the component class, the operations common to most of the GUI components are found in the component class. These are the base classes, just like last week when I was talking about the utils and all of the collections. And we had linked lists, we have all these things that were built off of base collections. Same kind of concept. We're building components and we're just making instances of components, like instances of text boxes, instances of windows and frames and things. So it's actually quite easy. The container class has two important methods that originate in this particular container. The container is to add components to the container, and then the set layout, which establishes the program to the layout manager, basically creating and applying a layout manager to the container so you can position components on the screen. And you're probably wondering, well, how does this? What do you mean by this? The container is what's holding everything in your hierarchy. So if you look in here, we see that the component container is a component that's used in the Swing interface. Inside of the container, we put all of our objects. So we create all these objects. We create a container. We put all of the objects that we're creating in the container, and then we can apply things on the container as a whole, as an object, so we can set the layout. And the layout is actually kind of interesting. Have things left justified, right justified, have things centered on the screen, filling the screen, not filling the screen, and we'll see some examples of how that's applied. But it's actually kind of, I like to use the word crude because it's kind of like not very flexible. Things, if you add a bunch of items to a list of things that are going to be displayed on a container, it's really just word wrapped, essentially. So you have to actually fix the layout to sort of get it to the way you want it to look. Nothing like using the resource library or the RC, creating an RC file or using the Visual Studio. Nothing like that at all. That you are taking and dragging and dropping things on a canvas, kind of like Visual Basic, C++, the Visual Studio products, allow you to kind of build items on a canvas. Same kind of concept. You're building the items, you're adding them to a canvas, but it's not done graphically. There are some tools out there that you can do. You can download the tool sets, and the tool sets give you nothing more than a GUI, what you see is what you get, kind of interface to it. And it's kind of very similar to the concept of web development, where you download one of these what you see, what you get web tools, and you drag stuff on, and once you save it, you end up with maybe 10 times as much code as you really need. So I don't actually recommend using that kind of an interface, because what ends up happening is you get tons and tons and tons of code that's all part of the support of the what you see, what you get kind of package or the tool, and it's hard to go through it. It's hard to manually edit it. And then when you start editing it, you mess it up. So if you kind of just take the time to learn the Java techniques, write it by hand, even though it is more work that way, you'll end up with a better running program, less code, less cumbersome. Doesn't require any third-party libraries to be installed either. So it runs a little bit more streamlined. We'll see how it works. We're actually going to build the interface to a text editor today, which is part of your assignment, actually. So the first component to kind of look at, and what I want to do is go through the components to just give you some highlights about what they do and things of that nature. You can't really learn how to do this without actually seeing it in action, so I'm going to show you an example. The Jlabel Object provides the text instructions or information. It displays like a label. So actually the easiest way to kind of comprehend all of this stuff is take what you'd normally think, like text box, label, button, and put a J in front of it. And there's your component. And you're probably going to be pretty close. And then look up, go through and look up the rest of it, and you'll probably find the exact name. So Jlabel. One thing to emphasize is if you do not explicitly add the GUI component to the container, the GUI component will not display when the container appears on the screen. Which is kind of interesting, because what ends up happening is a lot of people create all of these components. They figure out what they're going to use it for. They actually, even create the layout and stuff, and then they forget to put it all together. We'll see how it's put all together. But that's a very important point to kind of remember as you go through and we start looking at some of these GUI components. It's a matter of adding them to the container. If we don't add them to the container, we don't use it. They don't show up on the screen, which is a common problem, actually. And I've seen some programs already from some of you who have sent them to me for advice. And I go, great, looks all pretty good. Nothing is showing on the screen. You didn't add it to the container. You've created all this stuff, but you're not using it. It's not gonna show up until you add it. And I'll show you how to do that. So to make an interactive GUI program, what we're going to do is, to make an interactive program, you need components. We also need events, and we need event listeners. Kind of like, it's like any type of GUI development that you may have any experience with in other languages. If you don't have it in this at all, you can easily learn this. It's not a problem. So the components are buttons, windows, menus. So on the components, we can add listeners, and we can have events. So this is truly event-driven application development, because what we're doing is waiting for the user to click on a button, waiting for the user to do something, capturing the event after we've listened for it, and then we're proceeding to have something happen. And I'll show you how that works as well. So event listeners are interfaces that are basically just kind of like exception handling. They are capturing the I/O that's occurring, the mouse click, the mouse drag, all of the different motions. And they're providing the handler or the method that's going to be produced, that's going to be executed when the event is triggered. So we listen for events to be triggered, then we perform some action to handle them, essentially, which is the event of, let's say, event-driven programming. So GUIs are event-driven, generates events by the users when they interact with the GUI. Here's some examples: moving a mouse, clicking a button, clicking in a text box, selecting an item from a menu. In fact, we'll see that today demonstrated. When the user interaction occurs, the event is sent to the program. Many events might be actually part of and defined in the AWT.events, which is I'm also going to demo as well, and the swing events. So we have two separate libraries, not to confuse you. One is part of the swing, which you could use, or you could probably not use if you don't want to. One's part of the AWT Abstract Window Toolkit. Depending upon what you're trying to accomplish, you're probably going to end up switching to swing eventually, because you want the cross-platform compatibility. You don't want dependency upon the system that you're programming for. A lot of the AWT tools, they're platform-specific. Swing is more universal, more popular, used a lot more. So eventually you're going to use the swing route eventually, but a lot of people have legacy code. They have stuff using AWT. They don't like the swing. They don't know about it, so they don't use it. So AWT was around a lot longer. It was the original toolkit that came out for GUI. Swing came around later. So when you start seeing this in the slide set, you're probably going to end up just importing both and using pieces from here and there, as you might in terms of getting things done. So here's our events, and this is just a list of some of the events that occur that can be captured: mouse events, input events, things of that nature. Paint events, when the screen is painted, when the mouse moves, all sorts of different things. So there's 3 parts of the event handling mechanism. And what we're looking at is the event source, what component was actually clicked on, what component actually received the event, the object itself, encapsulated information that might occur in terms of a mouse click, a mouse drag, a keyboard entry, and then the listener, which is the object that notifies the event source when the event actually occurs. So we take those 3 components, we put them together, and then we have an event listener interface that we apply to it, and then we can go ahead and process events. So it's very similar, if you're familiar with C or C++, very similar to that kind of concept. Except for we don't have to implement our own event handler, it's already there for us. We'll see. So the programmer must perform 2 tasks to process the GUI element. Register the element with the event listener, which means the event listener knows to listen for activity. And then in terms of the second component, oops, it's scrolled up on the top there, implement the event handler method. My two turned into a 1. Oh, this is blurry. Okay, that's good. That's nice. At the end, I'll tell you the lecture number. I believe it's 8. It is 8. This is lecture number 8. I wouldn't attempt to read the blurriness on the slide. It's going to give you a headache. I did that for my Saturday class. So, all right. So, event listener interface packages here. I don't know. You probably can't read it anyway from your distance anyway. So, I don't even. Oh, maybe I'll just read it to you. I'll just continue reading it to you. So, all right. The J text field, the J password field. Same thing we have in, like, say, Visual Basic and some of the other Visual Studio products. And the reason why I mention this, a lot of you people probably are familiar with something C or C++, and maybe have used Visual Studio. Might be a bad assumption, but anyway, the text field, the password field, we probably know the difference. One shows asterisks, or it shows something. The other one just shows the text in terms of what the user types. So we have that capability. So when the user enters the data and then presses the enter key, the event is captured. We actually have the event of clicking in the field, the event of text being typed. In fact, you could write a program that essentially erases the text as the person types the text, which could irritate them. And then the enter key or the submission of we're done in terms of the capture. You can also capture words and phrases that are entered into the text field and use that as some sort of an event as well. And the example code here I have pulled out and I've put into a program, so you'll see how that works. Buttons. Buttons, is just a button. J button, as you might expect. So the button itself is a component. The user clicks on it, triggers an event. It comes from a subclass of abstract button. Because buttons actually are inherited, because we have J button, but we could have a button with a picture on it, a button with text on it. We can make a superclass of it to have the button and do anything when we want style-wise. So we can actually kind of customize our buttons. So created by JButton generates an action event that occurs from a click on a button. So we could toggle buttons, check boxes, radio buttons, all sorts of different subcomponents that are part of this in terms of the item event. So it generates an item event, part of the swing component, as we can kind of see. Here's what it kind of sort of looks like. We have the Jcombobox itself, the drop-down list. So it's a list of items that you can use to make a selection. It generates an item event. So here's what ends up happening. You start putting this stuff together. You go, I could make a Jcombobox. I can make a JList. And what ends up happening is, you have to figure out, do I want a single selection? That would be the JList. Do I want a multiple selection? That would be a list selection event that would be occurring on that. And then we find the events that are associated with the actions that we're doing. And most people would look it all up in a reference. You're not going to remember what event is actually called. Instead, you'll look it up, do a Google search, and you'll end up finding, oh, this event is triggered when a combo box is used or when a list box is used or something of that nature. So what I gave you was kind of a run-through of text fields, password fields, buttons, labels, lists, combo lists. These are all of the different components that we can put on the canvas. You can call them widgets, you can call them items, objects. We have to display them somehow. And when we do this programmatically, We don't have a drag and drop tool or a canvas that we're looking at. We have source code that we're writing. So what we do is we create a layout. And the layout is going to arrange our components the way we want to see them. There's a lot of noise going on in the back. I know it's from the surveys, but if we could keep it down, it'd be great. That way I don't have to yell over you. Hello. People are still talking. Hello. Thank you. Or you could go outside the door, too. The doors are wide open there. All right. And that way I won't be bothering you. Okay. All right, so all the components are positioned by the layout manager. The layout manager is going to tell us how these components are actually going to be positioned. This is what I refer to as the crude. It's low-level crude. It's not very feature-oriented, and I'm waiting for a new technique to come out that improves upon this concept. But we have different layout managers that we can pick from, and this is going to determine how our information is actually going to be displayed in our container. So the default layout manager lines up the components horizontally until there is no more room, and then starts a new row. So it goes like this, word wrap, essentially, which may not necessarily be your optimal layout. So resizing the container, the layout manager reflows the components automatically. So the layout manager is fixing our layout, and we put components on it to figure out how we're going to do our spacing. So we could put empty labels if we want of 50 characters, let's say. If we're going to do, let's say for example, we're going to do this horizontal. We're just going to do the default layout. We would go, a label that said first name, and we would put like a little space in there, and then we have another component with a text box where people would put in their first name. Then we could put an empty label on the end with 50 characters or whatever it was to fill up the lines in terms of the width. And then it would word wrap to the bottom, and we go last name, text box. That's what I mean by crude. That's really manual. However, that's what people do, actually. And you'll see in a few minutes, it actually kind of works out quite well in terms of placing the items. And I want to say that you'll probably spend most of your time with the layout manager. Creating the components is a no-brainer. Getting them to actually show up on the screen correctly is a problem, is a challenge. And unfortunately, I shouldn't say unfortunately, maybe it's fortunately for you, your menu in your text editor that you're writing for the fourth program is, you don't have to worry about a layout manager. You don't even have to worry about this concept at all. But if you ever write another GUI program, you're going to have to be putting these items on the screen. And you can play around with it if you want. You can add buttons and items and use a layout manager and populate your screen if you want. And I'll show you what I mean when we get to the source code part. All right, so the default is the center of the components in each one of the rows. You could choose alignments left, right. In fact, this is where we have layout flow left on the bottom. You can't read it. It's kind of blurry probably. Other managers, that link on the bottom will take you to more different types of layout managers that you can do. Potential problems with the border layout. In fact, if we use a border layout, what we're going to end up having is everything basically stretched out to the borders because it's aligning it and it's going to fill in the entire screen by the borders. So what we do is we stretch to fill in the entire screen. So we add other buttons to the region to displace the first button. So that's why I said we end up with empty buttons or empty labels that don't print anything on the screen, but there's a component there taking up space. So we can kind of position things out. And in that particular example that I just gave you with first name, text box, so we had a J label, a J text box. We have a blank J label that's just taking up space. So it fills in line by line. If that were the case, you'd probably use a border layout if you were trying to achieve that particular design. And that's kind of, I don't want to call it hokey, but that's how it's done, which is, has its strong points, has its weaknesses at the same time. Solution to it here, use extra panels. So we can add panels to the layout so that we have things, we have one panel here, one panel here, and one panel here. It's kind of like frames in HTML, or panels. We're separating out the screen in different regions. And then we can populate the items in terms of the different panels, and then we can apply a different layout if we wanted to each one of the panels. So think of it sort of like a hierarchy of components. You're going to have the frame inside of it. You can put different panels in there with different layouts and then different components that are going inside of each one of the different panels. So it's really a hierarchy of events, a hierarchy of placements that we're looking at. So in terms of the panel, it acts as a container for the interface elements themselves. Can use a flow layout by default. To fix the problem of the border layout, you create a panel, add components to the panel, and then add the panel to the larger container. And now you're thinking, this is kind of reminds me of HTML, actually, in the old days, when people used to write HTML code with frames, and then they put stuff in there, and then they put the stuff inside of that, and then they, oh yeah, let's create a table, table elements. So you have nested elements, very similar to how you would do HTML. So if you're familiar with the concept of placing items on a canvas with HTML, it's identical in terms of the theory. So here we have Jpanel P creating an object is a new Jpanel at the bottom, p.add button, p.add button, add button, which kind of gives you a sample of the code that you're using. And then frame.add, well, we're going to add the panel with the border layout, and we're going to specify we want it left, right, north, south, east, west. How do we want it essentially to flow? So at the end of the slide set, and this is basically all the theory that I'm going to give you because I'd rather show it to you in action, we have some supplemental reading here. These links actually I've tried recently and they work. I recommend the second one here, creating a GUI with JFC and Swing. Not bad. That one particular link, a nice little tutorial, has a lot of sample code. And then building a user interface on the bottom. It's a part of the Java, Sun's old attempt to create Java tutorials. A little lengthy, a little cumbersome, and each one of those tutorials is like 50 pages long or something. It's really long, but it's your choice. At the end of the slide set, so it's lecture number 8. If you are interested in pursuing a little bit more reading on that, and also if you want to read the slides, it's actually because you can't read it on the screen is kind of definitely kind of blurry. So let me make this a little bigger so maybe you can read this. Well, that's big. Alright, so what I have here, I have actually made a YouTube video out of this as well. So the video is more of a tutorial where I've actually kind of gone through line by line by line. I'm not going to bore you at this point because what you're going to do is probably watch the video, pause the video, write down the code. I'm not going to provide you with this code. So if you want to cheat, this will get you started with assignment number 4. It's not going to do your font menu, your style menu. It's going to do your, it's going to do the menu itself. And let's go back here actually. Not a bad starting point. Let's take a look at assignment number 4 because I know some of you probably haven't even looked at it yet. It's just a suspicion. So assignment number 4, let's take a look to see what we have to do. Then we'll know what I'm talking about. Alright, this looks extremely difficult. Oops. Not so bad. It's really easy, actually. In fact, you'll see I'm going to create most of it for you today. In this lab, we're required to program with Swing and File I/O. So we're going to, in fact, I showed you File I/O last week. That was the second part of the lecture. Opening, closing files, reading file streams, put input buffer, buffered I/O is what we talked about last week. If you missed that lecture, it's lecture 7. So your application is going to be a GUI, graphical user interface, that looks like this. Oh good, you can see it's big enough. That's good. I'm going to build the file menu for you, and you're going to build the style menu if you take this approach. Otherwise, you could build it all yourself and use your own style if you want. I'm not going to show you the style menu because I have to have you do something. So the GUI container has several different components to it. We just looked at these components for some of you who were listening to me. We looked at a JText area. We didn't look at a menu bar, but I'm going to show you that right now, or JMenu component, but I'm going to show you that right now. What we're doing is we're adding these components to our window, and we're programming the events for what happens when we click on the file menu, and we go file open, file close, and stuff like that. And so we're going to be looking at the event-driven behavior part of it, as well as the code that it gets executed. So let's see, this is just about all the different areas, text area, color. This is going to tell you about the J menu for the style. I'm going to show you the file because it's given for you. The file menu is going to have an open, a save as, and an exit. So, and that is the easiest part of the entire process. This one is not really complicated, it's just a little bit different. So you have to actually know how to do the file in order to do the style menu. Okay, so you're required to achieve the following tasks with these components. So if the file open option is used, you should be able to open a file window as below. You'll see it's one line of code, it does it for you. It's not hard. People who read through this and have no idea go, oh my god, it's too hard, I can't do the assignment. It's really easy. Alright, so you can open a file, double click on the file itself, already part of the UI. Hit the open button, automatically do it. So the contents of the file you selected should be shown in the text area. And only the contents in the plain text file is required to be shown correctly. So if the file has pictures, you don't have to show the pictures and things of that nature. And if the file doesn't exist, when you double click on the file, this won't be a problem, but if the file, type the wrong file, or if it might be impossible actually if it doesn't exist, show a message box to indicate such an error. So you're putting a little error message in there that says you click on something that doesn't exist, or maybe you can't open or something. And then if you click on cancel, the window's going to close and nothing's going to happen. So design of the open window is not your job. That's why I'm going to show it to you today. You don't have to design all this stuff yourself. It's given for you. It's already done in the JFileChoose class. So I'm going to demonstrate how to make an instance of that object and how to call the open, the close, things like that, and the save. So you can go to this particular URL. This is for the 1.4.2. It might not necessarily be the version of Java you're working with. I believe the classes are all the same, though. I believe there's nothing changed in terms of the naming. The implementations might have changed a little bit, but the interfaces are all the same. So you can check what functions and fields the class provides, so you don't have to figure it out. And then, as a message box, refer to the JOption Pane class in terms of an option box that you're going to be putting out. And I'll show you how to do that. For the file save as, you should open a file window as below. And then after you click on the file name, it basically is going to save the file for you. You're not required to handle double confirmations if the file has already existed, stuff like that. Because you have the event in which you save a file, but you're not doing it. You're doing a save as, but the file's already there. So do you want to overwrite the file? All those other questions and things. So this is kind of a low-level kind of text editor. Same as in task number 1, using the file chooser. You're going to use in terms of the file exit, it's going to close the program, close the file, and you should be able to change the font style, the background color, and the background color of the text area, the foreground color and the background color, the fonts that's showing up. That I'm not going to show you. You could do it yourself. I'm going to give you enough information, you're probably going to be able to do it yourself. Any questions about what we're building? Nope. Good. Let me show you what we're building. I have it all in a program called JavaPad.java. It's like Notepad. It's called JavaPad. I'm going to run the thing so you can kind of visualize what it is we're building, what it is we're seeing here. And actually that also will help me to make sure I haven't implemented any typos or errors in the system. I believe we are running. Here it is. Whoops. That's not what I wanted to do. When we run JavaPad, hold on a second. Here it is, my text editor. This is what it looks like on my screen. It's going to look different on your Windows screen. This is a Mac. So we have the little things. If I click on the File menu, I got Open, Save, and Exit. You're adding the one next to it that says Style. I'm not going to give that to you. This is going to look different, but this is essentially what we're going to build right now, what you're going to look at. Alright, so let me close it. Let me go back to the code. Oops, if I could find the code. Everything's so big on this computer. Let's see, there we go. Oops, not that one. Not that one. That one. There we go. Okay, so at a starting point, this is the new part. Well, actually, not all of it's new. This one we had from last week. IO. We're adding AWT, AWT event, and swing, because we're going to use both AWT components and swing components, and we're going to use the action listener, because we want event listener, because we want to do some event programming. Because when someone clicks on something, you know, we're going to want to see what happens. This suppress warning serial is just for Eclipse. Don't worry about it. If you're not using Eclipse, you don't. In fact, you don't have to use Eclipse for this either. You could write this in Notepad. You could leave that out. Actually, it's an Eclipse issue because we're doing file I/O and stuff like that. I don't know. It's a recommended. It'll give you a warning, but ignore the warning if you pull out that particular warning. And I'm not going to cover everything there is in terms of the idiosyncrasies of Eclipse. So anyway, what do we have? Just like any other Hello World or any other program you create in Java, we have the main Java class. And the public class JavaPad extends JFrame. Interesting. This is how we would actually create, let's say, an applet. This is how we would create an application. If we create an application, we don't have to extend anything because we're automatically extending objects, and it's assumed. So we could extend JFrame, which means we're creating an application, not an applet. And it's going to bring out, and what we're extending from is frame, which is our window motif. So we're right there. If you leave this out, you're going to end up with issues because you're going to be inheriting from something that doesn't exist. It's going to give you a problem. So that's actually a source of a lot of problems. So the components that we're going to use, as I mentioned before, we're going to create some items and we're going to stick them on the components. So the components here, we're going to have the text area. So we have a JText area. Hopefully this is big enough for some of you to see. I'm going to make it a little bigger. Here we go. Oh, that's a supersized. All right. Actually, it's even more supersized. I'm having fun with the supersizing today. All right, so what do we have? We have two components that we're looking at in terms of this application. You might actually have three. If you want to use a file chooser, it could be style chooser. Hint, hint. Because it's going to be a separate menu item. But actually, you don't have to use a file chooser. Well, you may not have to use a file chooser. You're building something to show fonts, and it's going to be a style menu. So you don't necessarily have to do that. You'll have to build a menu item for it, but you're not going to be choosing files, hopefully. So that's one of the considerations you actually have to think about. We're going to have a file menu, so we're going to go file chooser, create a new instance of this object, and this stuff is coming from Swing, actually, and it's extended from JFrame, which is part of the Swing components. So now we're going to create the actions for the menu items and the buttons. And remember before I said this action-oriented. And so we have action, open action is equal to new open action. And where are these coming from? It's coming from essentially file chooser. We have open action, that we're going to say exit action, save action. There's actually more than that. Not too much more. But this is primarily the events that we're looking for when someone uses our file chooser. These are what we're essentially going to want to capture. And this is a great example of how Java programs should be written. There's our main. That's our drive. And you might notice that we just have this in one file. I put everything in JavaPad.java. It's really the class for the application. The driver right down here, main, is going to be new JavaPad. That's it. That's our driver. So I figured just nest it inside a JavaPad. Makes it easier. Makes it, we could put it in a separate file if we wanted to. There's no need to. And just like any other Java program, we can have constructors. And so here's our first constructor. And I think it's our only constructor, actually, in here. It is the only constructor. When this particular instance of the object is created, it's going to build our application. The constructor is going to fire off automatically. It's going to create the scrollable screen area. So we have edit area, because we've already created the object up here. And then you'll see that this is actually very common. You don't have to do it this way. It actually falls through with kind of traditional style C programming when you create everything up, all the variables up front, and then you initialize them in the code lower down. Because up here I could see, well, what did I call that text area? It's not hidden in the code somewhere. It's right there up at the top. I can find it easily. Well, it's called edit area. And this one's called file chooser. So down here I've got edit area is equal to new text area. I'm running text area 1580, which is going to give me my line, my length and width, essentially, of my text editor. And then I'm going to set the border to a border factory, create empty border, which means I have just a line. I don't have like a thick colored border. You can actually play around with that and check out the different borders. Nobody knows, nobody memorizes all of these different methods. What you want to do is look it up. In fact, that's what all these Java reference books are all about. Pick up a nice swing book, because then you can figure out all the border styles, all the font styles, everything you want essentially to use. You can essentially look it up and use it when you're interested in it. Because there's like 100 different combinations you could probably come up with. So you could set the font, set the border, set the title. Actually title's on the frame further down, but this is on the scroll area, excuse me. So the scrollable text area. And so we have scroll pane, scrolling text. We created a scroll pane, which is going to be our arrow that's going to show up on the side. And the arrow, when I open up a file, because next time I show you the program, I'll demonstrate the functionality too. It'll add, right when you first open it up, there's no scrollable. When it's needed, it'll add the horizontal and the vertical scroll bars. And this is the scroll pane. If we left this out, we're not going to get a scrollable area, which means we're going to have to, open a small file in order to see everything. So here we're going to create the content pane, set the layout, and add the components to it. And if you're wondering about this code, again, as I mentioned before, if you came in a little late, it's on the YouTube video. So you watch the video, pause the video. Actually, you could do it right now. If you watch this video, pause the video. You could probably write it all down. You probably don't need to, though. Well, you might need to. Who knows? All right, so Jpanel. Remember those panels I talked about? We're going to create a panel, content, and we're just going to have one panel. And I'm going to load all the components onto that into that one panel because we don't really need anything. We don't want to have a complicated program. We're not creating any buttons or text areas or labels or anything. We just have a menu. In fact, nothing is going on the canvas. The content. This is the panel. We're going to set the layout to border layout. So it means it's going to run the text from border to border, and then it's going to scroll. It's going to word wrap it for us, which is not bad. And then the component content.add. We're adding to the component, to that panel that we created. We're adding the scrolling text. The scrolling text is this text in the window that's going to allow us with the arrow to go down and to go to the left and go to the right. We're adding it to the content, which is on the Jpanel. So it's the panel itself. Because what we're going to end up doing is putting the text area box inside of that. And then we're going to read a file in, we're going to load it into that text area. Here is essentially the main GUI. Now we have the menu to actually think about. When we create the menu, it's just like any of the other components that we've created so far. We're going JMenu menu bar. We could call it anything we want. Is it going to be equal to a new JMenu bar? And JMenu bar, excuse me. JMenu file menu. So the menu bar is that little strip that goes on the top. File menu is that little option. So you'll have to create one for style menu, if you want to call it style menu. And it's going to be, we're going to add it. So we're going to add file, and that's the title of the J menu. We're adding to the menu bar. So we create containers. We create components. We add the components to the container. So we're nesting, essentially. Once you get familiar with the nesting concept, it all works the same way. This you don't actually have to add. I put this in kind of to demonstrate it for you. It sets, in the old days they had GUIs where people didn't have a mouse. They could press like Control F, and then it actually automatically, and it gave you a little underlined. Anyway, that's what that's all about. Setting a mnemonic. So you set a mnemonic F, which means if I press F, either capital or lowercase, it's going to open up my file menu. You don't have to do that for yours, but now you see how it's done. In fact, that's actually kind of a common question you see a lot on some of the forums out there. How do we put in that underline under the F to make it so it's easy? Just add a mnemonic. So here we're going to add to the file menu. We're also going to add the open action, the save action, and the exit action. And then this guy here adds a little separator bar. Add separator. You know how you have a menu that says open, close, and then we have a little line, and then it says exit underneath. And all of this is just essentially just style. We see that in Windows all the time. In fact, this is a really Windows-looking menu. It just kind of looks kind of odd on a Mac because you never see a Mac displayed that way. But you know, it just kind of shows you the capabilities. And so an interesting thing to note is on the file menu is where we're adding the action, because that's where we want to look for it. So another thing that people forget to do, they'll add the menu item to the menu bar, but they won't add the action. So the action's there, it's defined, and we have the action handlers going on, but the action isn't being picked up because it's not added. Everything that we're going to use has to be added. So just remember, you have to add all components. Even if you don't see them on the screen, you have to add them. So we're adding those particular actions. So we set the window context in the menu here. Set the context pane to content, which is our original frame that we created up here. Our Jpanel, I shouldn't say frame, our panel that we created in our frame. We're extending JFrame in this application, so we're creating a frame automatically. We don't actually have to create the frame. As a side note, other languages you actually have to create the frame. Here, because we're extending it, we are creating a frame automatically. So we set the window context in the menu here. We set the menu bar to menu bar, or menu bar that we created the context. It essentially initializes it, makes it active, sets it so it's visible on the screen. And then we set the other window characteristics that we want. Here's where we're going to put the title in there. We're going to set the title to, my text editor. You can call it anything you want. Set the default close operation when you hit that little X, the red X that shows on the, minimize, maximize X button. We don't actually we do have that. It's on the left-hand side instead of the right on a Mac. Pack is actually essentially going to compress, put everything together for us. And then we're going to set the location relative to null, which means we're not going to have anything aligned. We could, we set the relative location on the menu bar where our menu items show up. It's going to automatically be left aligned in terms of the adjustment. We could actually make it so it's right aligned if we wanted to. Move all the options to the right-hand side of the screen instead of the left. And we could actually do that when we start painting the window. Set visible to true. We set it to false. We're not going to see the window. Actually, we're not going to see any. Yeah, we're not going to see the window. It's going to be false. I believe it is true by default. So if you don't even set the window visible, it's going to be true. It's going to show up. But someone could play around with you and just set it to false, and then you wouldn't know. My window doesn't show up. Nothing happens. Well, that might be a problem. Okay, so this was the main program, the JavaPad. In fact, this was the constructor of what happens when the program loads up. After the program loads up, we have those action listeners on open action, save action, exit action. That's the bottom part of this code that shows up in the file. We could put it first. It doesn't really matter where it shows up. It's kind of standard to put it underneath, actually. Actually, it's kind of standard to put this at the bottom, the main method. Which is kind of, so it's kind of displayed in a non-standard kind of fashion. And as we mentioned in the lecture, the short little lecture we had the abstract action. Now we're extending abstract action. Because we're creating a class here, public class, open action. So it's a class for open action. We could put this in a separate file if we wanted to. For simplicity, I put it all in one. Sometimes you'll see it nested because we'll see inner classes. Don't worry about the concept if you're not familiar with what I mean by an inner class, but it's highly tied to this class. So putting it separately doesn't do anything, doesn't benefit, and we have better scope if we put it inside this class because it really is nested as an inner class of this main class. All right, so our constructor here, open action. It's going to call super, which is the abstract action. If you're familiar, super is using the same concept as before. When we call the default constructor for the abstract action, which you don't know because you haven't seen the code for it yet, and you probably never will. It takes one of the items that it takes is the name of the menu item and the name of the menu. So when we pass it super open, we're saying we're going to call this the open menu. And I'll put a value mnemonic here. Same thing as we put before, the mnemonic key, if you remember that concept. So, okay, action performed here. This first action performed, what we had was the open action. Now we have a method in here, void action performed, which is going to take on an action event E. And you can go back to the I/O lecture from last week and kind of see that's an I/O event that's occurring. It's automatically being captured by the built-in facilities of the JVM. All we have to do is ask for it. So we get the event that's going to occur when the event actually does happen. Built-in functionality, all we have to do is know to take it on as a parameter because we want to use it inside of the method that we're creating. So what we're going to do, we're going to use the file chooser to show an open dialog. And the show open dialog is going to give us that little window. And we're sending it back to Java this, meaning we're creating it in terms of the input that comes out of that window is going to be automatically sent to this particular class that we're using it. We could call it, we could send it somewhere else if we wanted to. Like open it up into a new window. If we were going to open up a file and put it into a new class that we have running out there, which we could possibly do, then we would use a different setting for that. We wouldn't use this. In terms of here, we're saying this is kind of our error checking. If you remember last week I talked about I/O. A little different because this isn't really file I/O. We're using a swing component called file chooser that is a wrapped around file I/O for us automatically. So we don't actually have to open it up. All we have to do is read it. We call the method from this class that's built upon the lower class of the file I/O we saw last week. And when we do that, this is sort of like the concept of the file pointer in C or C++, where we create an integer value, we open a file, we assign it to the pointer points to the file. Kind of the same concept, and when we refer to it by the pointer instead of having to open up the file all over again constantly. So file F is going to be equal to the selected file, and its data type is file as an object. So we can run methods on it. And then we have our try and catch, and here's our I/O exception from last week, where we're going to try to open it up. If it doesn't open up, we can print something out to the screen. Here we're going to print out, the exception that occurs. This is where you can actually kind of do your error handling in the assignment description. That said, it's filing, print a message out. This is what it's talking about, actually. So use the text component to read. So text area, which is our text component, dot read reader. Reader is our file reader, built-in buffer. And this is kind of like Greek, but it's the standard methods that are applied towards the object of the file chooser. So if you want, you can go online and look at some of those references I had at the end of Lecture 8, and you'll see a bunch of stuff on the file chooser. Common. Everybody uses this technique. It's the only way, really, to read up, to select a file, open a file, read a file. And it doesn't really matter what file type you're opening up and reading. You can actually use it to run files if you wanted to. You can come up with a menu that runs programs or something. Okay, so that was the action performed for the method for the class open action. And now we have another inner class called save action, which is going to save the file, and we have another method, action performed, inside of that. So the constructor for save action is same as before. We're going to set the save in terms of the title. We're going to set a mnemonic to S in terms of the hotkey when we try to enter it. The action performed is going to be very similar again. It's the same code, which is why you write one program that uses the file chooser, they all look the same. But here we're going to say file writer, and we make a new instance. Instead of a reader, we're making a new instance of an object called a writer. And the text area that we're going to do, the edit area write, we're going to use it for the text area is going to essentially be for the write, write what's in the text area in terms of the object. And then we're going to catch the I/O exception if it occurs and show up a little dialog, message dialog The assignment actually wants you to actually show up a dialog, not use this. Actually, wait a minute, you know what? I should have taken that out. I gave it to you. This one doesn't use the dialog. That one's using the dialog I gave it to. Oh well. I didn't mean to actually give that to you. But this is what the assignment wants you to do, now that I'm totally showing it, giving it away. But only you guys sitting here can actually see this because it's not in my tutorial. It's in this one, it's not in the tutorial that's on YouTube. So, all right. So that's what the assignment's talking about in terms of this is going to open up a dialog box that's going to show you a warning. It's kind of like Visual Basic where you can have these little dialog boxes. Some of them have borders, some of them have close, some of them don't. Some of them have OK, some of them have cancel, continue. It's just built-in functionality as part of the swing. And then lo and behold, we have our exit option that extends again abstract action, the abstract class that we're providing us with our functionality. And now we have our constructor exit action, and then we have our action performed. Hopefully you're seeing the pattern. Hopefully. We have the class, which is the inner class, and then for each one of the classes we build a constructor, and then we build the action performed method. If we leave it out, it is an abstract class actually. It extends abstract action. If we leave out action performed, we're going to get a message, a nasty little error message that comes up that says we didn't implement it. Because you guys hopefully remember the concept of abstract classes, and that's why we do that, because we want to make sure that if we're going to have this exit action, we're going to have to do something. We're going to have to, when the action is performed, we want to process it. So it's kind of a way of creating a case in which the programmer can't leave it out. It's required functionality. And that is the end of the code, actually. So now let's kind of see what the activity sort of looks like, and I can walk through it. And I'm going to make this a little smaller first so I can actually see what's on my screen. So when I run it, and run it as an application, don't run it as an applet. If we wanted to create it into an applet, we would extend applet, actually. In fact, that was the purpose of that last assignment, was to take a program and turn it into an applet. And that's actually kind of trivial. It's really not that big of a deal. But it goes kind of above and beyond object-oriented design, which was really the focus of this particular course. If you're taking a true object-oriented programming course, then worrying about threads and how to convert applets into applications might be an issue. All right, so just as before, if I press, is it Control? Oh, there we go. On my Mac, it's Option, which is Alternate F. When I hit the Alternate key, oops, hold on a second. There we go. Make it bigger. We got our underlines that show up. That's the mnemonic code that I put in. So if I go O for open, oh, does it have to be capital? Let's just use my mouse. Open. Let's make it smaller now. That's my little dialog. This is the file chooser that shows up. So if I take and I open up a file, I think I have a text file in here. Test, text. I demoed it for the Saturday version of this class. So this is the test. So I can say this is Monday, not Friday. And then I can go File, Save. And it's going to open the dialog box again. Then that might not necessarily be the behavior that you're going to want in terms of your program. That's kind of irritating, actually, because some programs will automatically say, do you really want to save it? Or automatically save it and not have to hold up a dialog like this. This is the functionality I built in because I'm choosing to open up File Chooser again and do it this way, where I'm going to manually select the file. I can actually kind of change it and say like test1 or something, and then save it. Another thing you might want to do, and you can experiment with it depending upon how much time and energy you have, is it's really common to see the title appear. You can easily, from File Chooser, get file name from what you've gotten. The object information is there, and put up here, my text editor dash text1.txt if you wanted to. But it's not really part of the assignment. The other functionality here is the exit button, which is going to exit out. So it's not really going to do that, nothing too interesting here. And if you see, I can actually find it right here so I know it works. So if I open up test, it should take that piece out, which is the second line I put in. And then if I open up test1. It should give me the new file that I just created. So that is what you're doing. That is your fourth and last assignment. That should take you, what, an hour maybe, huh?
So in this example, the action should be fired.
I'm sorry?
The action should be fired by using open, save.
The actions.
By using an action listener or action event, which method we can?
You were gone. You were out of the room. Because if you were in the room, you would know the answer to that question already. You're extending, you're creating, extending, you're building upon the functionality of action, of abstract action, which is an abstract class for event handling. And we have included it. Here we go. We've created the actions for the menu and for the buttons. We don't have any buttons in here. We just have the menu item itself. Using open action, save action, exit action. So we have open action, save action, exit action. We're implementing the functionality here, and we're extending abstract action, which is the only option we have actually. You use the abstract action for everything, for catching button events, text events, menu events, everything. And you actually add this to the menu. We've added it. Where did we add it? We added it up here, actually. File, menu, add. We added the action events so that when the menu item is being selected, file chooser is going to open up.
Action event listener, we can do the same stuff.
Say that one more time.
Action event listener.
Action event listener, you could do it. You can use an action event listener part of AWT. Yes.
Same stuff we can do.
Yeah, actually, that's a very good question. I'm sorry, I didn't understand the first part of your question when the first time you said it. You don't have to use this technique. If you're familiar with AWT, you don't have to use the swing components. You can use anything you want. You can use action event listener. You can use. There's many other different ways. Actually, there's a couple of extra different ways of doing this. If you're familiar with it already, use the older techniques. If you want to learn a more modern way of doing it, use file chooser. Use action, abstract action. And you see, it's actually kind of easier. With the action event listener, you have to create the listener object, and then you have to attach the listener object to the component, and then you have to add the component to the. So the hierarchy is a slightly different format. I find it a little bit more complex, I think. I think this is a little easier in terms of demonstrating the concept. So, any other questions on it? So another question is going to come to mind, which I usually get by email. Yes, you may use this code. No, I'm not giving it to you. You have to watch the video. You have to actually write it down yourself. I'm not going to give it to you in the form of a file. But I've scrolled through it enough so that all you have to do is pause the video and write it down. But hopefully as you're writing it down, it's reinforcing the points. And I have not given you the style menu, so don't just give me this. Add the style menu. You're going to create another one. Probably not going to use the file chooser because you're not choosing a file. You're not doing anything with the files. You're going to be doing something associated with the fonts. And changing the font color and changing the background color of the text area. So if you can do that, that's demonstration enough that you understand how the components are working together and how the functionality should work. And if you're familiar, if you read through the notes, probably take about an hour maybe to do it. I don't know how. It shouldn't be a complex assignment. Nothing as bad as the hash map. So the worst assignment is number 3, I believe. So. Any questions on this assignment? Any more questions on this one?
Yeah, the path method.
Yeah?
Path method that is it extended from JFrame?
It is JFrame, yes. It's part of JFrame.
And does it change any behavior in our program if we don't use the path method?
Nope. I seriously, it's a matter of habit to put that in. If you leave it out, the program's going to run just fine.
So what exactly is it?
I believe it does garbage collection. I believe it automatically. In fact, garbage collection is the theme of next week. But it will eliminate, clean things up. Why did I call it pack? I don't know. Maybe I should look it up so I'm quoting correctly. But I believe the program will learn just fine if you pull it out. It's in there because it's like seals the envelope. It clears. I mean, it sets everything up, and then it cleans up. Because the show is going to show it. But a lot of times you'll see pack and then show for the the visible here. Oh, where's the visible? Because you might change items on the screen, and when you change items on the screen, if you run the pack, it actually refreshes it. Here, we're not changing any of the items, we're not doing anything, we don't have to refresh it. There's also a refresh, actually, as well. But the refresh, I believe, only does the current object in terms of what's being presented. It's not going to add any component, it's not going to pack it, it's not going to reset the alignments, the interface itself. So here's the visible down here. Actually, I should have just listened to myself talk. Usually you see the pack and then the visible because you're running them for the same purpose. And then here you're just setting, if you set the local relative to left, to right, run a pack, set the relative, and then run the visible. So normally you'll see the three of them. In fact, we could probably leave this out as well. We don't need to set the null. It's not going to come out. They're JFrame functions, just like the title is a JFrame function. So, and we actually have other ones. We can change the activity. We could take the buttons away if we wanted to. Remove the exit button. We now, remove the little dot, the red, the yellow, and the green, or whatever that is. The minimize, maximize stuff. We just left it on. Anything having to do with the window is part of JFrame. That's a good question. Any other questions? New? Alright, so next week is garbage collection. And it's also going to be the final exam review day. So I'm going to end kind of early today. It's not too bad. 4:15, not too bad. If we don't have any other questions, I'll see you next week for final exam review. Final exam review is not going to take the whole class session, and I'm going to wait for the second half because what's going to end up happening is I'm going to do it, and then half the class is going to show up. So I'll start the lecture on garbage collection, and then when that's done, I'll do the final exam review at the end. So, just in case you're worried about showing up exactly at the time of the class. And it's also going to be videotaped, or audio taped or whatever, so computer taped, so you can listen to it over and over and over again, and then quote me when you see a question on there that doesn't match. And just to give you kind of a forewarning as well, I've got a question pool of about 200. Well, actually, it's getting bigger now. It's about 250 questions. You're not getting 250 questions. You're getting 25 questions. And I'm working on it. I've got a way of randomly, it's a test program, actually, that randomly generates it for me. So you might get a lot of questions, like 5 or 6 questions on inheritance. And somebody else might not get any questions on inheritance. Or you might get, 2 or 3 questions on some subject. So what I'm saying is not everybody's going to have the same exam. And what ends up happening is I'm going to tell you, oh, study this, study this, study this, and you're going to come back and say, you know what? There were like 12 questions on inheritance. You didn't tell me that. Here's the problem. I can't tell you that. I can tell you which areas you want to be familiar with. What you get is what you get. It might all be an inheritance exam. Hopefully not. Because what I'm going to do is kind of randomly do it and then kind of look at them and then switch them manually. So hopefully you're not going to get more than 2 or 3 questions on a particular subject. But I'm just warning you ahead of time. I can kind of see that sort of happening. Hopefully it won't be a big issue. But maybe you're in luck. Maybe you'll know a lot about inheritance. Nothing on swing or nothing on anything else. But I'll tell you what to study for next week. So we're all done. All right, see you next week.